Hi there, this is Online Stats 3.4 additional topics in probability and counting day what? Basically, we're going to do permutations and combinations. Day 1 has got 3 examples, day 2 has got 2 examples, and I think then there's 3 on day 3, I'm not sure. Don't remember. We'll find out. A permutation is an ordered arrangement of objects. Remember, we got permutations, we've got combinations. Permutation is where order matters. So like think marathon, right? And there's a first, second, and third place, right? And you have 50 people who are running the marathon. You would use a permutation to find out the different number of ways that you could have a first, second, different sets of first, second, and third, as opposed to a committee where you don't actually have there's no role, there's no president or secretary or anything like that, where president or where just the committee members, it doesn't matter. You just have a 4-person committee. That doesn't matter how they were picked. So that would be a combination. Permutation is where order does matter, I think, is what I was trying to say in my rambling way. On your calculators, you're going to do the math button. You have to arrow to the right to get to the PROB. It might be PRB on some of your calculators. And then for factorial is number 4. So if I ever wanted, 9 factorial, that's where I would go. Because I wouldn't want to have to do 9 times 8 times 7 times 6 times 5 times, that would just be annoying. All right. So the objective of a 9x9 Sudoku number puzzle is to fill the grid so that each row, each column, and each 3x3 grid contains the digits 1 through 9. How many different ways can the first row of a blank Sudoku be filled? So here's the deal. In a Sudoku grid, you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And you have 9 digits that could go in this first. This is just the first row of Sudoku. There are actually 8 more rows that would head down there. So you have 9 digits, 1 through 9 to start with, then 8, then 7, then 6, because you're not allowed to repeat anything. Then 5, 4, 3, 2, and 1. This is 9 factorial, right? And there's 362,880 different ways that first row can be filled up. And remember, on your calculator, it would be math, arrow right to go to probability, and then number 4. That's your factorial button. The Big 12 is, I'm going to shrink this a little bit, there we go. The Big 12 is a collegiate athletic conference with 10 schools. Those 10 schools, how many different final standings are possible in the Big 12's football teams? And again, it's kind of the same idea. For first place, you could have any of the 10 could come in first place. Well, then that would leave any of 9 in second place. 8 of them have a shot at third place. 7, 6, 5, 4, 3, 2, and 1. So really this is 10 factorial, and that is 3,628,800 different ways for that to happen. You may want to choose some of the objects in a group and put them in order. Such an ordering is called a permutation. So you're not going to pick all of them. You're going to pick 5 of them. So if you had 20 things to choose from, you're actually picking 5 really. So you're still going to go to the math button. You're still going to arrow to the right and go probability. This time we want number 2. Number 2, when you look at it, it's going to be I have it written here, sorry. NPR, right? On older calculators, you're going to have to enter your number first, then go get the NPR, then enter the other number. You'll see what I mean in a second when I do this. All right, so find the number of ways of forming 4-digit codes in which no digit is repeated. Okay, so we're going to say that for our digits, we're going to use 0 through 9, which means that there are 10 total numbers to choose from, right? We want, of those 10, we want 4 because we want a 4-digit code, right? Okay. So order is going to matter because the code 1234 is different than the code 4321. Okay. So what you do, this means we have 10 total items to choose from. We want to choose 4 of them where order matters. So that's your total number. This is how many you want. That's how it always is. And then we are doing a P because we want permutation. Okay? When we do combinations, that middle letter will actually be a C. Some of the stuff you probably will remember because you've done this type of stuff before. So when you go to your calculator, if you have the newer calc, you go and select everything first. Like you actually go and enter all of these first, and then like it's those little boxes that show up. Remember that, like the little highlighted boxes that show up. If you have the older calculator, what you would do is you would type in the 10, then go hit all of those buttons right there, math, prob, number 2, and then you would type in the 4. And the 10 and the 4 would not be smaller numbers. They would not be subscripts. They would actually be like normal size numbers. Okay? But anyway, when you do that with your calculator, there are 5,040 ways to have a 4-digit code made out where no digit is repeated, made out of those 10 digits. Okay? All right. Let's look at this next one. A psychologist shows a list of 8 activities to a subject in an experiment. Okay. How many ways can the subject pick a first, second, and third activity? So we're going to say that order matters because it's first, second, third. How how he's doing this first, second, and third. That's going to matter. What do you want to do first? What do you want to do second? What do you want to do third? So he's got 8 total to choose from. I always say permute. It's just weird. 8 permute 3, right? And so there are, when we do this in our calculator, 336 ways for the subject to pick a first, second, and third activity. And by the way, there is a way to do this just mathematically without just looking at it. The formula I don't remember. It's like n factor. I don't remember. I don't remember the formula because the calculator works for me. So it does the job that I need it to do. But that's really what you need to know, is you need to know how to push those buttons in your calculator. All right, let's look at this last example. Each year, 33 race cars start the Indianapolis 500. How many ways can the cars finish first, second, and third? So we have 33 total cars, where order is going to matter because there's different monetary value for first, second, and third. So we're looking at the top 3, and there are 32,736 different ways to get a first, second, and third when 33 race cars start the race. All right. The board of directors of a company has 12 members. One member is the president, another is the vice president, another is the secretary, another is the treasurer. This is not like a committee where you're all equal and you all have the same power and same voice. When you actually have president, VP, secretary, treasurer, they all have different roles. It is all different, it's order's going to matter there because who you might want to have, be the treasurer might not be who you want to be the secretary and vice versa. Okay. But we have 12 members on the board of directors. And we need a 4-person committee where order is going to matter because we are actually assigning them a specific role. So when we do that in our calculator, we get 11,880 ways that can happen.